All right, let's take care of this practice test really quickly on writing quadratics, modeling functions, and operations with functions. So remember, we want to show all our work in thinking, make sure we circle our answer so it's very clear. And if we take a look at this first part, it says write a quadratic function that has the following features. So we basically looked at this in two forms. So we thought, hey, we're going to make it look like it's in vertex form, which is ax minus h quantity squared plus k. Or we're going to do it in factored form so we can see what the zeros, and that has an a out front. That's going to be the stretch, shrink, flip part. And then we're going to have x minus, we'll do x minus p, and then x minus q. And those are the zeros or the roots or the solutions, x-intercepts, however you want to think of it. So if we have the vertex right here, this is going to be the h, and that's going to be the k. So immediately we can write y equals, or f of x equals a. And then this is going to be x minus the x coordinate, so this will be x minus 2, quantity squared plus k, that's going to be a 3. We're almost done, we just need to know what a is, and in order to figure out what a is, we plug in this x and a y, because remember, if that's on the graph, it would work in the equation. So this is going to be negative 5 equals, this is still an a, that's what we're looking for, and this is going to be 4 minus 2, quantity squared plus 3. So this is negative 5 equals, this is, let's see, 4 minus 2, that would be 2, 2 squared, so this would be 4a, and then plus 3. I'm going to move the 3 over by subtracting, so I get negative 8 equals 4a, so if I divide by 4, I end up with a equals negative 2, and now I can come back here and I can write the answer. So this is going to be y equals negative 2, parentheses, x minus 2 quantity squared, and then plus the 3, and this would be the answer. And again, you can write y equals or f of x equals. Either one would be fine. This one has intercepts here and here, so we're going to write this down as y equals, or I'll go ahead and do f of x on this. So this is going to be f of x equals, we'll have a, and then x minus a minus 1. We'll take care of that in just a second. And then x minus 7. So minus a minus, that's going to count as a plus. And then we're going to plug in this point right here. Here's the x. The x is 9 and the y is 10. So we're going to do 10 equals a, and then this will be 9 plus 1, and this will be 9 minus 7. So this is going to be 10 equals a. This would be 10, and this would be a 2. So this is 10 equals, let's see, this would be 20a. We're going to divide by 20. So we end up with a equals 1/2. So now we're going to come back here and we're going to write, whoops, I should get in that habit, f of x equals, let's see, this is going to be a 1/2, and then x plus 1, remember that minus minus turns into a plus, and then x minus 7, and there's our answer right there. Okay, we'll take a look at the next one. This is vertex, so this is going to be f of x equals a x minus minus 1. Again, we'll take care of that in just a second. Quantity squared and then plus 4. So let's see, this is our x and this is our y. So this is going to be 8 equals, this will be a, and then this counts as a 1, a plus 1. So we're going to have 1 plus 1, quantity squared plus 4. So this is going to be 8 equals, this is 2 squared, so this is going to be 4a plus 4. So I'm going to subtract 4. So this gives me a 4 equals 4a, divide both sides by 4, so I get a equals 1. So here's our function. It will be f of x equals 1, which I don't need to write, so it's just going to be x plus 1, quantity squared plus 4. And we're all done there. So we'll circle that. And then the next one, we've got zeros. Remember, zeros, x-intercepts, roots, all those the same thing. So this is going to be y equals, and I'll do an a, and then x minus minus 5, and x minus 4. So this is going to be a plus. So let's see what we get here when we plug these in. So this is going to be an 8 equals a, and then 3 plus 5. 3 minus 4, so this is 8 equals, this is an 8, and that's a negative 1, so this is negative 8a, divide by negative 8, and we get a equals negative 1. So we're going to have y equals negative, I'll just write the negative there, and then this is x plus 5, and x minus 4, and circle that, and we are finished with that one. Okay, let's slide down here and take a look at this. Same type of information, but this one we've got a we've got it in graph form. So you'll notice that on number 5, we've actually got the vertex and we've got the roots. So either way would be fine. I'm going to go ahead and do this in vertex form first. This is going to be y equals a, and then x minus minus 3, so that's going to count as a plus 3, plus 4. And then I'll pick one of these to plug in. I think the -1, 0 would be easiest. So we'd get a 0 when we plug in a -1. So this would be a -1 plus 3 squared plus 4. This would be, let's see, that's a positive 2. We're going to square that. So we're going to get 0 equals, this would be 4a plus 4. Move the 4 to the other side and divide by 4. And we end up with a equals -1. So this one would be, and I'll write y equals negative x plus 3 quantity squared plus 4. That's one way to write it. And then I'm going to change colors for this next one. This one would be, if we wrote this in using the, let's see, the roots, the zeros, this is going to be y equals a x minus minus 5. And then this is going to be x minus minus 1. So this is going to be y equals a x plus 5 and x plus 1. And then we just need a point that it goes through, and we'll make it go through the vertex. So we're going to plug in a 4 for y. And let's see, a -3 here. So this is going to be -3 plus 5, -3 plus 1. So this is going to be a 2, and this is going to be a -2. So we end up with, let's see, a -4 between the two of those. So this is 4 equals -4a divided by -4. So we end up with a equals -1. So we'll come back here. Interesting. Turns out the same way either way. It will look different. This one's going to be y equals negative, and then x plus 5, remember, and x plus 1. So we'll make it look like that, and we'll put a box around that guy right there. So the interesting thing is they look very different, but if you were to go through and multiply these together, we'd have ax squared plus bx plus c. These would all work out to be the same numbers, whether we squared this out and added the 4 or multiplied these together and multiplied through by a 1. Interesting part about this is you can probably guess what the a would be. It'd probably have to be a -1 because it hasn't been stretched or shrunk. Okay, let's take a look at this next one. On this one, we're stuck with number 6. We've got to do this in vertex form, so this is going to be f of x equals, we're going to do a, and then x minus 1 quantity squared minus 3. Remember, this is the opposite when we plug it in with the x, and this is the same. So this is going to be, we get a 5 out when we plug in a 5, so this is going to be a 5 minus 1 quantity squared minus 3. So this is going to be 5 equals, let's see, this would be, let's see, 5 minus 1, that's 4, square that. So this is going to be 16a minus 3. Move that over to the other side by adding, so we're going to end up with an 8 equals a 16a. Divide both sides by 16, so we get a equals, we get a 1/2 there. So here's the answer, f of x, and again, you can write y or f of x, doesn't matter. We're going to have a 1/2 and then an x minus 1 quantity squared minus 3, and there we go. Okay, the next part is pretty calculator intensive, so I'm going to go ahead and pull that up. So when we're trying to determine what the data or what model best fits the data, it's going to be exponential, linear, or quadratic, and we're going to have the calculator figure out most of that for us. We talked about first level differences, second level differences, patterns that we could look for and stuff like that. Most of the time, especially if we've got real data, we're going to rely on the calculator to graph that for us. So I'm going to go in here and I'm going to hit stat and I'm going to hit edit. And I've already taken the time to put these in, and I'm going to come back here to L1 and L2, and we'll just double check. So we hit stat, edit, and then I can type each one of these pieces of information in. I've got the information in L1 and L2, so I'm all ready to go. And then I'm going to hit, let's see, stat plot, so that's second y equals. I'm going to do number 1. I'm going to turn that on, and by default, the scatter plot is selected. The X list is L1 and the Y list is L2. So as long as we've got the list that we want in L1 and L2, this is going to do the work for us. So the next thing I'm going to do is I'm going to come over here to Zoom, And we want to have this just graph it, pick a nice window. We don't want to have to worry about, okay, what's the x-min, x-max, all that sort of stuff. We just want to get a good look at this. So if we go down to number 9 or we hit number 9, and I've got some extra stuff on here, so I need to clear that off. So we're going to hit graph again. So it looks like this. You'll notice that it goes up and then it goes down, which we can kind of see in this. We've got 6, 21, 40, and then it goes back to 25. The only one of these models that works for something like that is a quadratic. So we're going to hit stat, we're going to calculate, and we're going to do a quadratic regression. We're going to do number 5. So we can either hit number 5, arrow down to number 5. I'm going to hit enter. There's our L1 and L2. We don't have to worry about storing the regression equation or anything like that. And we are going to round to the nearest hundredth if it doesn't work out well. So here's what we end up with. The A is negative 5.44 or 45. So 44, 45, that's going to be negative 5.45 x squared. The B is going to be 23.06. So this is going to be plus 23.06 x. And then the C is going to be, it's either 60 or 61. That 7's enough to bump it up to a 61. So I'm going to put plus 6.61. And that's our f of x. We'll go ahead and put it in f of x form right here. And I'll try and make that look like an f of x. Okay, so there's our answer on this one. And again, you'd kind of suspect that this would be negative because it starts small, gets bigger, and then it gets smaller again. So we're looking for a parabola that goes like this. We've got to have a negative coefficient for a. And then let's take a look at the next one. I'll get that ready to go. Okay, so I've got L1 and L2 replaced here. You can double check them yourself. I took the time to do that. So we're just going to come back here. And the cool part about this is I've already got the stat plot set up with L1 and L2. So I can just hit zoom again, and it's going to show us what this looks like. So I'm going to hit zoom 9 because that's the zoom stat. And you'll notice that we definitely don't have a line. We've got something that runs along here and then gets really big. That's probably an exponential. So we're going to come back here to stat. We're going to calculate. We're going to do an exponential regression. Exponential regression is the 0. So you can either hit 0 or go to exponential regression. L1 and L2, we're going to come down here, have it calculate, and we get this right here. So this is going to be f of x is equal to, the a, the coefficient out front, is 284. That'll be either 95 or 96. That's going to stay 95. And then we're going to have our base, and the base in this case is 1.23, and then we're going to raise that to the x. So there's our answer on that. Let's flip the page over and take a look at the other ones. Okay, we're on the back side now, and I've got number 9 all set to go. I've got 1, 4, 7, 10, and so forth. The next one is 2, 10, 3, 11. Double-checked all those. So again, because we've already got our stat plot set up with L1 and L2, and that's where I stored those, I'm just going to hit zoom. We'll hit 9. We'll make it do all the work. And you'll notice that we've got a nice line here, which if you take a look, this is 210, then 311, then 409, then 512, and 614, and 708. These, we're basically adding 100 every time. Now remember, actual data is very seldom going to match a model perfectly, but we think this is going to be a linear regression. So let's go ahead and hit stat, calculate. We're going to do a linear regression. That's number 4. And come down here, we're using L1 and L2. We'll tell it to calculate, and there we go. So we end up with, we'll write down f of x equals 33.35. Yep, stays 35. So 33.35 is the slope, and the y-intercept is 177, 177.17 or 18. So 17 or 18, that one's not enough to bump it up. So this is what we get right here. So we're done with that one. Again, the cool part about this is the calculator does all the heavy lifting for you. Let me come back here and let me just show you really quickly how I'm changing these. So I'm going to go to Stat, and we're going to click Edit. I want to replace this list, so I'm going to come up here and I'm going to click Clear. We never hit Delete, so I'm going to hit Enter there. And I'm going to hit Clear and Enter. And then I've actually stored these lists ahead of time. I've stored the ones for number 10 at the very end of this list. I made some new names, A and B, so I'm going to come back here and watch what happens when I do this. I'm going to hit Second and Stat, And you'll notice that I've got down near the bottom of the list, you probably don't have this, but I've made one called A. So I'll come back here and I'll grab this, hit enter. So I want L1 to equal the list A. Notice that it has an L in front there, so I'm going to hit enter. And then I'm going to come over here, and on L2, I want one called B. So I'm going to hit second in list and come down here. It's number 8, so I could have just hit that. And then I say L2 is equal to LB, list B. And I hit enter, and you'll notice that these are all the right values. So now I'm all set to go. So I can store those, set them equal to each other, move them around and stuff like that. So I'm all set to go. I'm not going to take the time to figure out what I think this might be. So let's just go ahead and have the calculator do this for us. So I'm going to hit zoom and 9. So that's zoom stat. And this goes down and then up. We can kind of tell from the values in the 400s down to 300 and then back up. So this is going to be a quadratic. So we're going to hit stat, calculate, and we want to do a quadratic regression, so number 5. We've got everything all ready to go, hit enter. It actually takes the most time actually just typing this stuff in. So this is going to be f of x equals, so it's either 53 or 54. It's going to be 1.53 x squared. It's negative 23, either 63 or 64. That's not enough to bump that up. So this is going to be negative 23.63 with an x on there. And then the constant at the end is 472, either 60 or 61. That's going to be enough to bump it up. So 472.61. So we'll put a box around that. And then we're all set to go with the other ones. I think we can probably do this without a calculator, but let's take a look and see what happens here. So we need to do these operations with these particular functions. So we're going to take h of x, subtract 2 times g of x, and then we're going to add 1. So let's see what happens there. H of x, that's this one, so that's going to be 12x squared plus x minus 6. And then we're going to subtract 2 times g of x, that's this one, so 3x minus 2. And then we're going to add 1 on the very end there. So here's our h of x. There's 2 times minus 2 times g of x, and then plus 1. So let's go ahead and distribute through here and see what we get. This is a negative 6x. This is a plus 4. So let's go ahead and combine like terms. I only have one x squared term, so that's going to be 12x squared. I've got some x's here, so that's going to be a negative 5x. And then I've got some constants here. I've got a negative 6, a 4, and a 1. So these make 5, and that's a negative 6, so we're going to end up with negative 1. So here's the new function, and then we also want to consider what is the domain of the function. Well, these original functions, they're just polynomials, linear functions, quadratics, stuff like that. The domain is going to be from negative infinity to infinity. We can plug in anything that we want. We could spend some time graphing this, but we know roughly what this looks like. It's a parabola that opens up. And we know that through the operations, we haven't done anything weird. We haven't done any division, introducing domain issues that way. We don't have any square roots of negatives, no danger of that happening or anything like that. So the domain on this is going to be from negative infinity to infinity. Okay, so there's the other part of that. Don't forget to find the domain. Now we're going to multiply the two of these together. So we're going to take f of x times h of x. So here's f of x times h of x. So we got a lot of multiplying to do here. But remember, these have domains that are from negative infinity to infinity, all real numbers. And when we multiply, that doesn't introduce any domain issues. So we should see a function when we're done that doesn't have any square roots, any division, or anything like that. So we're going to take 4x plus 3, and we're going to multiply that by 12x squared plus x minus 6, and multiply through here, here, and here. So this is going to give us 48x cubed, and then plus 4x squared, and then minus 24x. Now it's the 3's turn, so this is going to be plus 36x squared, plus 3x, and then at the very end we get a minus 18. So if we put these together, we've got a 48x cubed. Done with that one. The squared terms give me plus 40x squared. Done with those. The linear terms give me negative 21x. And then the only thing on the very end is a negative 18. So here's our new function. And then, like we said, this is just a polynomial. You can plug in anything you want. So it's going to have a domain from negative infinity to infinity. You may run into people that just say it's all reals, and that's totally okay too. Let's take a look at this next one. We've got division here, so we're going to want to be a little bit careful with this. We've got g of x, which is 3x minus 2 on the top, and we've got h of x, which is this guy right here. So this is 12x squared plus x minus 6. So we've got division. We need to be a little bit careful. What we can't have is this cannot equal 0. So if we've got division, can't be dividing by 0. So I need to factor this and see what the factors are and what would turn that into a 0. So this is a hard trinomial. I can't take out any GCF or anything like that. So I'm going to multiply the two of those together. That's negative 72. And I'm looking for numbers that multiply to be negative 72 that combine to be positive 1. So I could go through a list like 1 and 72, 2 and 36, 3 and 24, and so forth. But the most common numbers that we use to make a 72, think of our multiplication tables, are just 8 and 9. And I want them to multiply to be a negative, and I want them to combine to be a positive. So one's got to be negative, one's got to be positive. But if they're going to combine to be a positive, the bigger one's got to be positive, the smaller one's got to be negative. So let's see what we get here when we factor this. This is going to be 12x squared plus, or I'll do minus 8x plus 9x, then minus 6. I can take out a 4 and an x out of the two of these, so 4x. We're left with a 3x minus a 2. Out of these two, I can take out a 3. I'm taking out a positive 3, and I'm left with a 3x minus 2. So this is going to factor to 3x minus 2 and 4x plus 3. And this is what's in the denominator. So let's take a look here. This is 3x minus 2. And in the denominator, let's go ahead and write this. 3x minus 2 and 4x plus 3. Now, we are going to be able to simplify this. These two are stuck together. I could cancel those off, and I'm going to simplify that in just a second. But we want to consider that we've still got this issue of division. So this cannot equal 0. So we want to consider what the zeros are from this. So the 0 that comes from this one is x equals 2/3, and the 0 that comes from this one is x equals negative 3/4. So if I plug in a 2/3, it'll turn this into a 0, making the entire denominator 0. Can't have that. If I plug in a negative 3/4, it makes this one 0, times that one by 0. The whole denominator would be 0, and I can't allow that. So these are the two things that we can't have. So we're going to throw those out of the domain. So the domain is going to be from negative infinity to infinity. We'll just throw out those two numbers that it can't be. So it can't be x. So we'll say x not equal to 2/3 and negative 3/4. That's probably the easiest way to say that. And then let's write the simplified version of this. I'm going to go ahead and cancel those off. Remember, you can cancel factors, not terms. So we're canceling this entire factor with that entire factor. So it's going to be a 1 on the top and a 4x plus 3 in the denominator. So here is the answer for our new function. And we've got the domain right there. So I'll just draw a line on that one so we can kind of separate them. Okay, let's take a look at the next one and see what we get there. We've got h of x over f of x. So we've got h of x, which is going to be the 12. And in fact, I'm going to go ahead and simplify this here. Let's just go ahead and write down what those factors were. If we take h of x, we're going to have to factor it anyway, so we've already got the work done. 3x minus 2, 4x plus 3, and we're dividing that by f of x, and f of x is 4x plus 3. Now, you'll notice that these are exactly the same. We're going to cancel those in just a second, but remember, this still can't equal 0 because this is the original function. This is what created our simplified version. So our simplified version, if we cancel these, is just 3x minus 2. That's our simplified version, which looks like it's just a line, and we could graph that. But remember, if those cancel, we still can't have it equal whatever would make the denominator equal to 0. So the domain is going to be negative infinity to infinity, but we're going to throw out that one value right here. So we're going to throw out negative 3/4. Okay? So there's the original. We canceled the two of those. We made this function right here, the 3x minus 2 on the top. We do acknowledge the fact that, hey, you still can't plug in a negative 3/4 because that would turn the denominator into 0. Okay, let's take a look at the last couple. Mop this up here. So on this one, we've got the same functions, and we just want to evaluate this. We want to find g of 3, and we want to subtract h of 3. So g of 3 is going to be what we get when we plug in a 3 here. So this is going to be 3 times 3 minus 2. And then h of 3 is going to be this one. So that's going to be 12, 3 squared, plus 3 minus 6. So let's get an answer for this one. That's going to be 9 minus 2, so we end up with 7. And then we're going to subtract whatever the answer is for this. Let's see. That's going to be 3 squared, that's 9. 9 times 12, that's 108. That's going to be plus 3 and minus 6. I get 111 out of the two of these, and then I'm going to subtract 6, so that's going to be 105. So this is minus 105. So if I do 7 minus 105, I end up with negative 98. So there's our answer on that one. Let's take a look at this next one. We're plugging in a negative, so we want to be a little bit careful with this. And we've got some multiplication here. So f of negative 1, so that's going to be 4 times negative 1 plus 3. So that's going to be negative 4 plus 3, so I get a negative 1. So this first value right here is negative 1, and then I'm going to multiply it by 3 times whatever I get out of g of negative 1. So that's going to be, let's see, g of negative 1 is going to be 3 times negative 1 minus 2. So that's going to be negative 3 minus 2, so I end up with a negative 5. So let's see, if I have a negative 1, and then this is going to be a negative 15, I end up with 15. So we'll go ahead and circle that, and there's our answer. We do want to make sure we know, so this turned out to be a negative 1, kind of unique like this. When we plug in a negative 1 into that function, we actually get a negative 1. Then we're going to times 3 times whatever g of negative 1 is, and when we plug in a negative 1 here, we get a negative 3 minus 2, that's a negative 5. So this right here is the final calculation, and that's why we work out with that answer. All right, good luck on the quiz.